Then I would say let's go, let's start. I'm pleased to welcome you to our today's lecture in Object-Oriented Programming 1. Actually, the second lecture that we have this semester. It's a pleasure for me to be here for the first time, actually. David did the introduction last time. I was absent last week since I had another very important meeting to that time. I will take this opportunity to just briefly introduce myself. I think most of you might know me from ESP already, but yeah, just one or two words on myself. I'm Alex Steinmaurer. I'm postdoc at the Institute of Interactive Systems and Data Science, and besides that, I'm also working the other half at the ITU in Linz, so the Institute of Digital Sciences Austria, also as postdoc in the founding team. Yeah, together with David and a bunch of very motivated teaching assistants, I have the honor to take over this class and this course. Today, there might be one thing happening that I just want to introduce you briefly before we start. Some of you might have already realized that there is something at the blackboard in front of us, so the letzte Generation might come over today, so don't get worried. We had this already in project management today. They will just say a few things and then they will leave again. This is all communicated by the rectorate, so no need to be worried, so everything will be fine in that case. All right, let's go.
Yeah, let's go. So I want to say in the beginning, we saw in the practicals that there are some problems with Menti, so we decided to use Slido. So in this lecture, we also want to have it a little bit interactive, and you can already sign in or log in with the QR code or with the website and the ID. And we will have a few questions where we want to know what you say or what you think about that. But of course, when we come then to the questions, you will also have the possibility to log in. So I think we can go on further. And this is our schedule for this semester. We already are finished with the kickoff and introduction to C. And I think today is the lecture where we go into object-oriented programming.
Right,
And this is maybe the most interesting or one of the most interesting or most important lectures, because we introduce you to the topic of classes, and classes are the one topic of object-oriented programming, so to say. So classes are very, very important. So if you decide to stay, it would be beneficial for you. All right. But before that, I think we can do a short recap. Michi and Julia also showed you a few things from last week, but this is already the first Slido question for you. There are also possible answers. You can join, as I said, with slido.com and with this code, or use the QR code. And the question here is, how could we improve this code you can see here? I hope it is visible for you. What kind of improvements could we do here? Let's wait. So I think, how many people are there? I don't know. Hard to guess. But let's say we wait until 50 people have done it.
Sounds good.
That's also a test if you paid attention to the practicals today, because I think all of it was already discussed in the practicals.
It's already more than 50.
Yeah, quite impressed. Thank you for the high number of participants. Can we reach the 100? I don't know.
Almost.
So 11 left for 100, but I think 100 is hard to reach. Maybe also we need you two to participate to get the 100. I think we are done.
I think we're good.
I think it's hard. Maybe next time. So yeah, what improvements could be done? This is what you said. And yeah, very cool that you spotted the range-based for loop. So what we can do is, instead of this for loop here, we could use, of course, a range-based for loop. We have seen it in the practicals before. What we also should do is using a reference here, because otherwise this vector is copied, and this makes it much more convenient. And we could also use the vector at, but when we use the vector at, we do not use the range-based for loop. So yeah, one of those would be good. Default parameters and use std string in this case doesn't really make sense.
We don't even have a string in that.
We don't even have a string, yeah. So this is, once again, what improvements could be made. As I said, we want to have a reference here. We want to use a range-based for loop. We could also use a reference here. Yeah, these are the main improvements, what we discussed last week and also in the practicals today. All right, I think there were already some questions about that topic, so I think we can continue to our first very, very small topic, because this is just one slide, and this is something which is left over from last week and also from ESB, which are called enums. I hope you are familiar with enums in C. They are easy things to enumerate some stuff, and the cool thing in C++, as you might have seen from structs already, we do not need, again, this typedef keyword, so we can just write in C++ enum, then we have an exam, and we say, okay, the exam could be finished or is currently running, and then we can use this exam. So in this case, Alex already finished the exam. Congratulations.
Thanks.
The other thing in C++ is so-called enum classes. So what you could do is write enum class and then exam. And the cool thing is then that it is like a namespace, so you can use the same names inside. There is no conflict then. And for example, we have an exam which could be finished and running, and also a marathon could be finished or currently running. And yeah, so you can use both declarations in different contexts, but just using this like the class name or the enum class name before. It is, I think, very straightforward because it's like the C version of enums, except you don't need to write the typedef before. All right, and then I think we go to the main
Today's
topic.
main topic, yeah. Let's talk about objects and classes. So basically, when we have like the figure here of two pets, a cat and a dog, we want to think of both animals or pets in terms of which attributes they might share. And we came up with two very obvious ideas. They might have a type, so one is a dog, one is a cat, and they might have an age. And actually, this is the whole idea of classes. You think of things that you want to group together, abstract things, and actually build classes around that. We will talk about classes a lot in today's lecture and also in the next lectures. But we know this concept already, kind of, yeah? We worked with structs already in C, as you can probably recall. And in C, we had, when we were talking about structs, we had data types that we combined to another new thing, yeah? A book that consists of authors, pages, a title, obviously, or in that case, a pet that has a type, an age, and whatever. So this side should be quite clear already. What we have on the right side is the C++ equivalent to that. So as you can see, we just wrote struct pet. Now we can use the std strings as a nice top-up for C++. And besides that, everything is quite close to what we already know. I mean, this is the same initialization and declaration that we already have here on the C side. And here, yeah, it's standard C out instead of printf, so also quite similar. And yeah, actually, from this perspective, classes and structs are kind of similar, but structs, classes provide us with much more details and much more possibilities. So when we refer to the structs as we just saw them, structs is a way to have different members. This also is often referred to as plain old data classes. And the plain old data class is just a composition of a new or different data types to a new data type. We call those things members, or sometimes you might also read fields in the literature. And yeah, this is the C way how to go. This is kind of nice because we can have a new data type, but what we now want to do in C++ and also in other object-oriented programming language is to have something new, something called classes. So in C++, we have this example here, as we already told you, with age and type and the object, so nothing new here. Let's have a further look of what a class actually is. So the most obvious thing that changed is here. Instead of struct, we just wrote class. Yeah, this does already a good job because when we do this, C++ knows, okay, we want to have a class here. Yeah, besides that, type and age stayed the same, and also here nothing changed that much. So we also have access to our member type and age. So from this perspective, nothing changed that much. But if we have a closer look at that, we will get an error. So if we take this thing, put it into a compiler, then we might run into an issue. And this says, okay, error type underscore is a private member of pet. Okay, there is something that we don't know from C so far, and this is called a private member. And we will talk about this today in detail. What does it mean to be private or to be public? And what we add here is a so-called access specifier. We just write here public. In comparison to C, we can define in C++ if we can access a specific property or field, or if we can do that. The question that might rise up now is, why shouldn't we have just access to some of the member variables? And this might get clear over the entire course because there might be some information that we want to hide from others. And this is the reason why we have to do this and to define these access specifiers. We have some examples today that we will show you also to get a better understanding for that. Will you talk a bit about what the access specifier actually does?
Yeah, sure. So in the last case here, as Alex already said, we have a public access specifier, and this is necessary that we can access here the members, so the type and the age, because when we go back in this case, this here is no public access specifier, and when we want to access the type and the age of this cat, it says that it's private, we cannot reach it. So there are obviously many access specifier, and there are 3 in detail, but we will talk about 2. The third one is, I think, for next time. We will talk about it, or
fourth lecture, I guess.
Or the 4th lecture. Yeah. So public and private. What does this mean? So public members are, as we have seen before, accessible from everywhere. This is like from C already, you can access all the members in a struct, wherever you want. The other thing are private members, and private members can only be accessed within the class, so also within the struct, and from outside it's not visible to the outside world. It only can be accessed within the class. The question might arise, how could I access a member inside a class? We will come to that. There are, of course, more than just members, but for now on, please think of private means that you cannot access, like we have here, you cannot access the members directly when you have here a private. And the other thing, when we go back to this slide, is we did not declare here private, but it is obviously private. So this is a rule of thumb for you. In general, if there is no declaration, the class assumes that you want to make the members private. That's why it is private. Of course, you can write private there. It has, in this case, no effect because it's already private, but we will highly recommend you to write private, to have it stated there that you want to have it explicitly private.
And in comparison to structs, you don't have to write this. So this is one of the differences between those two keywords. If you have here struct instead of class, then it works. Because we have to be somehow compatible with C, because there everything is public actually. And so this is the reason why class are private members, and with structs it's public. So you can access the things as you already know from C already.
Yeah. So these are the two access specifiers we want to talk about today. The third one, protected, is, as I said, we will talk about it in the lecture 4. It has a few or more advanced topics which you have to know before. All right. So this is called, and this is one of a very, very important concept of object-oriented programming. This is called encapsulation, or in German, Kapselung. So you want to hide specific information from outside. Maybe you have a main function and you have your class, and you do not want that you have or can access the members inside the main function. But as I said, the question is, why should we want to do that? So we have, in this case, I think that's your example. Yeah, perfect. So let's suppose we have this code. Again, it is pretty much the same. We have a type, we have an age. We create a pet in the main, set the type, and set the age to 60. Looks fine.
Looks fine, yeah.
In the first place, but I think you've done research on that.
I did comprehensive research on that, and I figured out after reading tons of literature that cats don't get that old, actually. Yeah, so they're usually around 12 to 18. So setting age to 60 might be a bit too much. And this is actually why I thought of a way to, inform the user that this is not possible to set it that high. I mean, I would love to have a cat that is like very
60.
old, 60, to survive me.
Like
but
Green Puff, I think this name could only be in Britain.
Yeah, yeah. So there is a 38-year-old cat, obviously, but yeah, we don't want to deal with that situation. So 60 is definitely too much, and therefore we want to provide an interface, and this interface should inform us of certain things. So is a number higher than, like, I don't know, 20 or something? Or if we have a function or like a method where we have a where we want to divide something, we shouldn't divide by 0 or something like that. So these kind of things should get checked. And for this reason, we provide this interface, and this interface is called a setter. This is also another concept in object-oriented programming that you might hear a lot, and this is different among other programming languages as well. So you will also have similar concepts in C#, in Java. So yeah, a lot of programming language are using this kind of feature. And so what a setter does, it sets the value of a member in a controlled way. So not like before where I just write the value into a variable. Here it's in a more coordinated way. And what actually happened here is I said the age is private, but I want to give the user a chance to set the age. And therefore, the user has to work with this method, and this method is the setter. So I called it set age. This is like something that you commonly write. You just say set, and then the name of the variable. And then what happens is that from outside, since this is public, I can have access to this method and pass a value. And if this value is less 20, then everything is fine and the value is set. I mean, we could also check for a lower boundary and say it shouldn't be -1, for example, wouldn't also work. But we could do these kinds of checks here. And then I say, okay, if this is the case, I want that age, so this member, is set to the value that I pass to the function. We will also see the main function in a second, and then you can see how this looks like. We also have a getter here. I will come to that in a minute. This is like the opposite way. We don't want to just write things, we also want to read things. So here you can see how this works in a main function. We have pet cat, and now we want to set the age. And by just saying cat.setAge, I set the age to be 5. And if this would not be the case, so if it would be like 20 or 21 or whatever, this wouldn't work. So I could define here a different behavior. For example, the user will get some kind of error or whatever. Yeah, so this is on the one hand the setter. And as I said, there is also a getter. And this is to get a value. Also similar idea, we have a private member and we have a method. We will talk about what a method exactly is in a minute, and say, okay, I want to get the age and just return it. Since this is an integer, I will return it. This is something that we know already from C. So this is like a function in C. We say we have a return value, we have the name of the function or the method in that case, and we just have a return value. We will talk about this const at a later point in the semester, but what I can promise you so far is by writing const here, we promise that we won't change anything within this function with age, because we promise that we just want to get something. It would be a strange side effect if we set something in here, and so the const means we don't touch anything here in the age.
So with touch, you mean we do not modify, so
Right.
let's say we increase the age.
Yeah, for example.
Yeah. And one comment from my side, also here, of course, we know that this is not conform with our style guide, but yeah, it's hard for us to get all the classes onto one slide. So please, yeah, we have to do it, and we know it's not conform our style guide. You should do it, of course, like we have described in our course website. All right, yeah, this was the getter, and as you can see here, you can then access with get age, similar than the set age function. All right, we have another Slido question for you about these concepts we have talked now. So this access specifier and setter and getter. So what is the output in this case? And I mean with the output, really what is printed in this case? Gives us the possibility to drink, to have a break. seems to be a little bit more challenging than the last one.
Probably. In the meantime, are there any questions regarding set and getter which are not asked here?
Are there actual set and getter like in Java?
The question is if there are keywords as set and get as we have in other programming language. Unfortunately not.
So yeah, you have to implement it on your own. So every setter and every getter you want to access, you have to implement in the class on your own.
Yeah, I think
yeah, most of you should be finished, and it is, great. So most of you have spotted it.
But the question is why? Can someone explain?
Any ideas why there is a compiler error? Yes? Yeah, so you're completely correct. We have no includes. That's correct. We would assume that the includes are already there, but as you said, we are missing here the public or wherever. So in this case, all of this, so the age member and the set age and the get age, so the functions and the member are private. And when I want to access them here, like set age or the elephant to get the age, I will get a compiler error because the compiler said you cannot access it. It's a private member. So far, so clear. Or are there any questions to that?
Frage auf Deutsch. Kann ich die Klasse gleich als öffentlicher Public erkennen?
So the question is, can I make the whole class private or public, or just declare it somewhere here in the beginning? No, that doesn't work. You have to define here private or public. But what you can do is, for example, you can write private, age, then public, I don't know, type, then again private, and so on. So you can choose however you want. You can sort it whatever way you want. But it's not possible to declare a whole class as public. In this case, so the question is, where does the error occur exactly? It will occur here. So we can create the pet, the element, or the elephant, but in this line here, it's a compiler error because we cannot access the function inside the class. Okay, some of you have changed your mind. Interesting. Let's get the elephant on top, yeah. I think we have to wait.
The SPU, right? Was it where the elephant was on the list? So it's the same here.
Yeah.
There was another question. What the reason is?
You, of course, now the question arises for you, but you will see it when we have a few examples, and you will see it in the next weeks or so, why we want to have the members private.
There will be many cases where you want to have like this controlled access on the variables. So in very rare cases, you want to have a real public member because, or like a field or a variable, you usually want to access it via a set and getter to do something with the value, like to have some additional check or whatever. So this is the reason, actually.
So in this slide, we had the problem like that. Of course, we are also the programmer, but let's say this is a user input here, and the user wants to say that this cat has an age of 60, and we want to, we don't want to allow this. So in this case, we create the cat and say, okay, it shouldn't be possible that the user should input the age of 60, and we can handle this situation, and for example, tell the user that this is an invalid age.
Does this clarify it a bit?
Yeah, in C structures is always public.
So if you would write here actually, struct, then you would have exactly what you just supposed, yeah?
All right, the elephant is still
in the room.
What we also have is, and we teased it a bit already, we do not have members only. So cat, for example, do not have only the age and the type. It has some behavior. And we want to work with this behavior. So we had the properties, so the type and the age. But what these pets also have is, for example, they can move, they can make noises, sometimes annoying noises, or whatever. So pets have so many possible behaviors, and we want to implement it also inside the class. And what we can do is, like we implemented this getter and setter, we can implement methods. And methods are, as you can see, again, here inside the class. And we could implement a method called makeNoise and do whatever we want to do inside. In this case, we print that there's an arbitrary animal sound, okay? And we could also implement a method called move. And as you can see, it's a normal function. So it has a return value, it has a function name, it has parameters. And this makeNoise doesn't have parameters and have no return type. But then we can call cat.makeNoise. So we execute a method or a function of this specific pet, of this object. So we create the object and then call a method of this object. Depending on the members, so the properties of this object, we could get, of course, different outputs. So let's say we have, again, a dog and a cat, and the dog can make different noises than the cat. So depending on when I write here cat.makeNoise or dog.makeNoise, there is, of course, a different output. So methods are pretty similar to functions in C. Of course, there are also functions in C++, but they are part of the class and they are declared inside the class. So basically, methods are, and we will use this notation method and member from now on, I think, in every lecture, because it is the main thing in object-oriented programming. So when we talk about methods, please keep in mind they are just functions inside the classes.
Yeah, and we will talk now about one specific function inside a class, like one of the most important one, the so-called constructor. It's used to create an object. So what happened here already, we created objects. We didn't do that much to reach that goal, and we will have a look at that. And as we have here the word object, and this is like part of our lecture name, you can assume that this is really important what we're going to tell you here today. So we're talking of a way to create a new object. And I just want to show you this particular method. And this is the constructor. You can see the name is also the same name as we have here in our class or struct. and we don't have a return type. So what we usually have when we talk about methods, we have a return type. Here we don't have one. And this means if we don't have a return type and the same name as in the class, this is a constructor. And what we do here is we set the age initially to 0. So we can, when we create an object, define what the object initially should look like. This is the idea here. This is something that we already know. So we have a getter here, so nothing new, but here, this is the idea. In that particular example, we also have here pet, and we set a bit more. We set the age, and we also write I'm alive and age years old. And if I run this now, the program will output I'm alive and 0 years old. And this happens why I just write here pet p. And what's happening under the hood is that as soon as I write this here, as soon as I have this declaration here, the constructor will get called and will create this object immediately. So I don't have to call it. This is something that we usually do when we want to get some behavior of a function or a method or an object or whatever. We call something. So if we want to call a function, we have to write the function name. We don't have to do this. So this happens here automatically. There are also other techniques to deal with the initialization. There's a question. It also works with the struct here.
But yeah.
I set it here to private and public, so it works. But as you mentioned, we could or should actually write here class, but it would work since with this access specifiers, we say that this is private, so age is private, and the constructor is public.
So yeah, thanks. But I think we wanted to write class there.
So class and struct both works as soon as I define the specifiers as I want the behavior to have it. Thanks for realizing that. Yeah. Any other questions?
So if you declare an object, it's already initialized.
The question is if I declare it, if it's also initialized. In that case, since I have in the constructor here the age set to 0, yeah. If I call here p gets age, then I will get 0 back. So this value is set here already.
Empty object. How could you set it to null? Would it then be initialized?
So you mean if we set this to null, this does not work because it's not a pointer. It's an object already. Of course, you could create like a pet pointer and set this to null, for example. This would work.
But this wouldn't create...
But this wouldn't create the object then. Yeah, it's just a pointer to a pet. But when you write it like this, it's already an object. It's like a struct object. In this case, it's a class, or in this case, it's really a struct object. And then the constructor is called. You cannot set this to null or whatever. But you can use different kind of creating the pet. I think this is what we have here. So we used this first constructor, and as you can see, we can write more or many constructors inside of a class, or in this case, a struct. So we use this one because it's just we creating the pet, but we could also create the pet and hand over an age. So at the creation, we want to say, okay, this pet should be, I don't know, 10 years old. And then inside the body of the function or inside the body of the constructor, the age is set to age. So this is also important, and it's also sometimes a little bit hard to get. So this here is the member, and this is why we use this underscore here at the end. And this here is the parameter. This is why we always say it also in the structs in ESP and also now in OOP1. Please write here at the member variables of a class or a struct always this underscore in the end, because then we can identify what is the member and what are just parameters or variables. So in this case, this parameter here, or the value of this parameter, is stored into the age of this object then. And we could also use another constructor here where we want to give the age and the weight, for example. And you're using here a quite interesting notation.
Right, this is an initialization list, and we would encourage you to use this one because this saves us from a lot of trouble. What we actually do here, we leave the body of the function or the method or the constructor, whatever, we use it, we leave it blank. What we do here, we say we are having two members that we want to set, two member variables, and with this column here, we're saying we set the age variable here, so the member, to this one, and the weight to that one. So exactly the same when you call it, like when you call or when you create the object, but different in a way here, since we don't have to use the body of the constructor, and this is why we also should use it, so we don't have to deal with things like reinitialization. What happens sometimes if you won't do it like that? You will hear later when we're talking about constants and references in detail that this way of initializing might be much more easier and safer also for us. Yeah, I want to go back or jump back to another example that we had previously today. We had this example here. And what I can see in this code is that this works, but I talked a lot about constructors and how important they are to create an object. But I would say I don't see a constructor here. So the question is, why does this work actually? So what's the reason behind that? Are there any ideas why does this work? Yeah. Oh, that's a good idea. There is something hidden that we don't see actually. Yeah, like some super fancy magic happening here. And you're completely right. Yeah, actually there is something which is called a default constructor, and this default constructor helps us because when we don't define a constructor here in our class, then the compiler does this for us. So in that case, this works just because here a default constructor is added. So that's the idea of that. So in that example, I have one of the constructors, but this is a constructor where I should also set here the age of the cat. And here I get the following error, no matching function for call to pet. Why is this the case here? I mean, I just said I have a constructor here. Yeah.
Because you can overload a function on C++ with different input parameters.
Yeah, that's true, but that's not the problem here. So what this means here is you go into the namespace of pet, in this case it's the namespace, the class, and call this function inside, and this function is the parameterless, so without parameters, constructor here. Yes?
Yeah.
Adding a constructor makes the default constructor, removes the default constructor.
Right. So our colleague here said that if we already have a constructor, then we promised kind of that we will take care of this. And so the compiler says, okay, you said you have a constructor here. We will also talk about destructors, so I'm mixing things a bit today. We'll have a constructor here. So you might want to declare one explicitly. And that's the case here. As soon as we have another constructor here, this won't work again. But what we could do is the following thing. We could say, okay, we have pet and set this to default. This will work and will do exactly the same job. So if we run this, it would work.
Is there a difference between the default constructor and an empty constructor?
No. So the default constructor is just an empty constructor, where the default constructor and also the empty constructor do not change the object. It's just creating the object, but it's just it has an empty body.
You could also write, instead of default, you could write pet and then have the brackets here would do the same job. All right.
Yeah.
But you prepared something.
A short quiz again. I wrote there some statements. I hope they are correct about constructors, and it's up to you now to find out which statements are correct. So if they are correct, just mark them. If not, don't mark them.
Can you make the constructor private so you can't initialize it?
The question is, can you make the instructor or the constructor private? Yes, you can do it. There are cases where you want to do this, but this is, I think, a few lectures ahead of us.
Yeah.
But there are cases where I want to do it. For example, when I use a singleton, I have this case. But normally I want to have constructors public because I explicitly want to create the object from outside. All right, then let's have a look. That looks quite good. So constructors do not have a return value. That's correct. As we have seen before, it is just the object. So we write class pet, and the constructor name is then just the class name, in this case pet. There is no return value inside.
I see what you're doing here. I mean, I think Slido is a cool tool, but
Yeah.
this should freeze actually and not.
Yeah, but it's also interesting what they want to get up.
Yeah.
The name of constructor is always just the class name. That's correct. So yeah, as I said before, the name is, so you take the class name. This is the name of the constructor. There's always a default constructor. No, as soon as we do not define, or as soon as we define explicitly a constructor, the default constructor is missing. So we have to then define the default constructor additionally. You can create a maximum of 3 constructors per class. I have to hurry up because
It's climbing up, yeah.
Yeah. You can create a maximum of 3 constructors per class. Does not work. Yeah, it does work, but there you have, I don't know if there is a maximum number of constructors. Never tried it, but there are definitely more than 3. And last thing is initializing list only works for the constructor without parameters. That's not correct. So you can write the initialization list wherever you want or at every constructor. Only constructors, and of course not when you have methods. This does not work. Yes?
It's technically no return statement in the constructor, but isn't it returning an object of the class?
Where do we say that?
Yeah, kind of. Kind of, yeah. But the constructor as method has no return value in this case. Yeah, but I know what's your point. Of course, they are like returning the object, the finished object, the created object. Yeah. Yes. In C++, I think it's not possible. No.
How do you mean it exactly? So do you have an example what you mean? I mean, you can have a class or an object in a class again, so that would work.
Yeah, but you cannot write class pet and then inside the class, let's make another class. This does not work. So what you could do is you could create or have an object of another class as member of a class. This works, of course, because let's say you have a class pets and you have a class, I don't know, legs. Every pet has legs, hopefully. No, not every, but let's assume every pet has legs. So you could have an array of 2 or 4 objects of the class legs inside the pets. But you cannot declare class pet and inside class legs. This does not work. Yes?
Actually, you can define a class within the class, and then you can access it like you would with the namespace. So you can write a pet class. Within the pet class, you write class legs, and within the pet class, you can just use the leg class. And from outside, you can also use it if you write pet colon legs.
Really? Okay, I've never tried it before, to be honest.
Okay, so our colleague just said that you can do that by using the scoping operator. Thanks for clarifying that.
Thanks. I've never tried it, to be honest, but I assumed it. Yeah, we also have learned something. Thanks.
Okay, whoops. We talked about creating a new object. Now we want to talk about how to destroy an object, actually. We will do this in particular in the next week. Today is just to at least once mention that you can do that. So very similar to the constructor that we have here, we have a destructor here with the tilde here, and so actually it has the same syntax as a constructor, but just with the tilde here. What happens if you actually run this code on the right side is the following. First, the constructor is called, since we create the object here, and then the destructor is called when we go out of the scope of the cat. We will talk about scope, or a lot about scope, next week, where we will see what different types of scope there exist. But we had this already in ESP in the first semester, where we saw that variables have a different lifespan, and this might end, for example, after a function or within a block of an if or whatever. So these kind of things end here the life of our cat, which seems very sad, but
that's hard. Yeah,
that's
life. A hard statement.
Yeah,
I don't want to end the life of my cat, but I just want to call maybe I should call the destructor of my cat.
Call the destructor of the cat.
So the Destructor is the perfect place to freeze a memory.
Yeah.
Yeah. For example, so in a case where we, for example, get some memory from the heap. Destructor would be perfect place to actually free all the memory, since after that, we will lose it probably and get some memory leaks. Yeah. There are some things that you also should avoid to do in a destructor. We'll talk about that in detail because also some pitfalls. So it's the place to do these things, but it's also a place to be careful with other things. Yeah. All right. We saw a way to initialize variables already or objects already. And this is another way to use the so-called Brace-Initialization. And this is a feature from C++11. And what we have here is a class which is very boring because, yeah, we know already what happens there. But here I say, within the brackets, I initialize the cat called Schnurli, and she's 5 years old. It was the name of my first cat, actually, and so and she got 5 years old, so I thought this would be good to honor her in front of all of you guys. So my Schnurli got 5 years old. After that, the destructor of the cat got called, so to say, in form of a car.
Yeah. Cars are often calling the destructor of cats.
Yeah. So this is another way to initialize. Also a pretty good way actually to do this because we can avoid also a lot of pitfalls by that. Just to mention, you can also do this with primitive data, so like with integers or whatever. So you can say you have the age of the cat. Here it is initialized, and this is why it's called initialization and not something different, like assigning. We initialize a value here. So we say our cat is 4 years old. We increase the value by 1. And what would raise an error would be if I say here, again, age of cat 6, for example, because this is just for initialization purposes. All right.
So this initializes all public members.
When you go back to the last slide.
Here in that case, yeah, since all of them are public, yeah.
It also initializes private.
No, actually, it calls the constructor here, which we don't have in that example. But this calls the constructor for the name and the age. That's the deal here. What also could be used, or what is another advantage of the Brace initialization, it helps us when it comes to narrowing. What is narrowing actually? If we use it like that, then the system will say, okay, you cannot do that because this is an integer, and the integer cannot be 7.9. So this might cause some problems here. What would happen if we do it like the C way, like to say we assign it? What would happen if we assign 7.9 to an integer, usually in C? Traditional like exam task. Yeah, so what actually would happen is you cut this off and it's 7. All right, and another cool thing, it's a uniform syntax, so doesn't depend what you want to initialize. So the plain old data classes, arrays, vectors. We'll talk about these things in the next classes. But as you can see, you can use all of this here, and this gives you a uniform way to deal with initialization. All right. Do you want to talk a bit about UML diagrams or?
Yeah, sure. I think we have 50 minutes left. It works perfectly. So we talked a lot about classes and about members and methods, about access specifiers or private members and public members. And yeah, let me just have a question in the room before. How many of you already worked with UML diagrams or know what it is? From another course at university or?
Who knows it from another course of university? Who knows it by job?
Okay.
School?
Next.
That was the point.
Oh. Cool, okay. Yeah, we have to guess, I think. That's interesting. So, yeah, we will talk a little bit about UML diagrams, and I think our first homework will also be about UML diagrams. And what it is just like a standardized language to represent classes, so to say. So you can show a relationship between classes, between components. Of course, today we only talked about one class, mainly our pet class.
Right.
But as you might can imagine, we will, or you in your assignments, will have many classes, many different classes. And what this UML does is shows the relationship between classes, because sometimes or often classes have some kind of relationship. A class can be a member of another class. As I said before, a cat can have legs. And of course, let's say, I don't know, if you have the class university, university has students, so the class university could have a member, a vector of students inside. So there is some kind of relationship between classes. And this language helps us to use it. Do you want to show it with this here? I think we can just open it. I don't know if I'm logged in now.
No Rickroll.
So this is one possibility. Of course, there are many possibilities, but I just want to show this you once. These are the most common icons used when you use OML diagrams.
Or diagrams in general.
Or diagrams in general, and they are quite convenient for that. And I think you should also, or you will use this website for your assignment.
You can also use other ones. So this is just an example. I like to use it, but you don't have to. So I don't force you to use my tools.
Yeah. So what is an UML diagram? So this is an example. We have, let's say, a student. So this is the class name. So as you can see, it's like a diagram. We are not into coding now. We want to represent classes and the relationship of classes. And these are my member variables of this class. So a student has obviously a student ID, a first name, a last name, a date of birth, a date of enrollment, an email, and a study program. Here you also always write the data type. So we have primitive data types like an integer or a strings. We also have more advanced data types like a date. We don't know a date yet, but it could be, for example, just another class, which represents then a date. And here we have methods, so functions in this class, which are called methods. For example, a student can register for a course, can deregister for a course, hopefully not from our course. List courses, so you can, for example, say alex.list courses, and I can see all the courses Alex is enrolled currently. Wouldn't be that much, I think. But you are holding a few courses, so that's good. And you can calculate the GPA, for example. So these are the methods, and these are the members. And another thing is, maybe you spotted here this minus or this plus symbol. They are just indicating if this is a private member or this is a public member. So as I said, this is a class name. We have the member variables and the methods here. Do we have anything left? Any questions?
Is there a symbol for protected?
Yeah, hash. But since we haven't introduced it formally yet, we avoided it here, but there's also a symbol for that. I mean, everyone who suffered creating UML diagrams in school already knows that there are a lot of different notations to do these kind of things. We will provide you with like some ideas how we would love to have this, but in general, I would say it's dialects of UML. So there is this uniform language, but there are some different types on how people or most teachers want to have that actually. Because when I draw these kind of things in software projects, it looks completely different all of the times.
So if you have a large project, of course, you have, I don't know, 10 or 100 classes here. So it can be quite messy, but it helps, especially you as a programmer, or when you're doing, or managing the whole project, it helps a lot to get an overview or to have or keep the overview of all your classes and how they interact with each other.
Yeah, and speaking about interaction, we will talk about this in detail next week, where, I mean, we spoiled it already a bit. We have a pet, but this is quite boring because we want to have particular pets, like a cat, a dog, a turtle, an elephant, whatever. Maybe an elephant is not a pet, but yeah. So you can have different types.
I read it.
You had it, yeah, right. The elephant, yeah.
Yeah,
right.
I have a big flat at home. It works. I have an own elephant room.
So we will talk about these kind of things next week, how to deal with similar attributes and yeah, how this works with like inheritance actually is the keyword next week. So thanks for being here today. We'll see each other next week.